for later. And I will go ahead and share my screen here. Of course it is. What did it share for me? Let's see what it's sharing. I guess it's kind of sharing. Looks a little bit different. Okay. I don't know that this is sharing. Hang on a second. I'll try it again. WebEx meeting window. I don't want to share the WebEx. I want to share my screen. Bear with me. It's a little bit different, as I said. Usually I got to move a few things around here real quick. All right, let's try this one more time. Can you see Programmable Controllers Week 1 Allen Bradley ControlLogix PowerPoint and hear me and see me? Wonderful. All right, yeah, they change the software every little bit. All right, here we go. So what I have right here is the Week 1 PowerPoint that I already sent out to you guys, and then the video here that I asked you guys to watch, 1 or 2 times. And so this is the PowerPoint that we kind of went through in class just briefly, and then your lab covered, all this, all this other stuff here. And so my point was, between, watching that video and just kind of going through this PowerPoint, what you read in the book, and then the lab, did this kind of tie it in together that, oh yeah, that's kind of what I did, and I see it a little bit here. So I like to ask everybody, just on a scale of 1 to 10, did this kind of tie it all in together for you? What do you think? Got a yes. Okay. You got an 8, an 8. Okay. So it's getting around the software. 9.9, that's always good. We're going to go over it some more here, but just kind of getting around the software and everything was what the first week was about, and the way that the controller works and the way that it's organized and everything. And that's what the first video and kind of what this first little PowerPoint is for. And like I said, we're going to kind of revisit it a little bit here, continue our little crash course on it, and then move on to some timers and some safety relays and stuff. Okay. So it says welcome. I take attendance automatically. I can just see who was here and what was going on. Pass back papers, I do that all on D2L. So homework 1 should have been turned in. A lot of people were turning in homework 1. And then it says collect lab 1. There was maybe 1 person or two people maybe that were going to finish it up on Saturday, and then have it ready for me next time I see you. Take it signed, so it says who is behind. Well, I haven't checked. Oh, wonderful, John. Yeah, and then you can just, as we go through this, hopefully it makes sense. Thank you for that update. It says who is behind. So hopefully you're not too far behind. I'll take a look at the homework and, see where you're at and being sure you're all caught up. And you do not want to get behind in this class. All right. So the week 1 PowerPoint and video. So this is where I was talking to you. It's pretty straightforward, based directly out of the textbook. The first lab is focused on using the Studio 5000 software. I encourage you to watch the video. And I encourage you to read all of the textbook material and reflect on the PowerPoint. And I also post a lot of reading on the D2L, okay? Especially now that we're gonna get into some safety relays here, there's gonna be a lot of reading. And so, my disclaimer and, what we talked about before is that I'm here to cover the overview, to point you in the right direction, but there is an incredible amount to learn. And if you're not used to really reading a lot, really digging in on these labs, really looking on the videos and digging in, you're going to struggle in this class, because this is going to, starting tonight, it's going to start to be a bit of a beat down. But if you prepare yourself, and I just encourage you to prepare yourself as much as you can, then you're going to love this class. You're going to learn a lot. But if you're just looking for the answers, and you don't understand what's going on, it's going to get pretty ugly pretty quickly. Okay, so I'm going to jump right in once again, as our crash course to ControlLogix was our configuration. So what we had to do, first of all, was we had to configure the communication. And so what you did is you went into RS links right here. You wanted to use RS links to set up an Ethernet IP adapter, and you set that up by going into network. The video showed you, and there was instructions in the lab, and some of you just remembered how to do it. But that's where we went into the Ethernet adapter here, and we went into properties, and then we went to TCP/IP4, and then we set it to 192.168.1, and then the last number. There's no lecture worksheet. No, you guys can not watch this lecture. You can watch this lecture. You can take a nap. But as I stated, you know, I'm not yelling at you, okay, you will learn the material if you're going to pass the class. So I'm leaving it up to you. You're kind of big boys and girls now. You're on your own. Okay. So the 192.168.1 was our network that we set up. And we're not talking about class A, B, or C networks. So we're just going to stick to this network for now. Be aware that the last number has to be different. So if your USB to Ethernet adapter, here mine is 20, okay? Your partners can't be 20. The PLC can't be 20. The VFD can't be. It has to be a different one, because this is essentially saying that this is my computer, okay? And then I use that to connect up to a PLC bridge, which was 10. My computer's 20, the bridge is 10, and then I can see everything. But you have to have a last number. So Ethernet IP private network that we have going right here, your understanding of it, scale of 1 to 10, where are we at on this? Wonderful. Yep, should be 10. And so what happens is you're going to have to come in likely every day and reset this up, because my other PLC with class was in. Remember when you did SIC 500s the first week and you set some of this stuff? Well, that all got changed and broomed and unplugged and replugged in. And in introduction to automation, those that have had that, you did all this already, and it got plugged and unplugged. And so you're just going to want to be sure that you can get in here and do this. Okay. So when we go to number 1 there, that was what we had to do, is we had to configure the communication. The next thing was we wanted to configure the CPU, and we wanted to configure the IO rack. On our CPU, we were using version 28, okay? What I've got going right here, what's cool, is if I go to my links right here, it shows me what my little rack here. And if I right click on my here and go to device properties, you can see that my processor is version 33. So when I show you my software in a minute, it's going to look a little bit different, because I said that there's for Studio 5000 here, you can run version 21 all the way up to 38. This one's actually running on 33. You're running on 28. Okay, so that's a good start if you're not sure what type of software you need. But the software revision level has to match the firmware that's been loaded in the controller. Now, your controller, which is an ELTE261 controller, I can flash it with the 33 if you have the 33 software, or I can flash it with the 38 if you have a 38 software, but they must match. Scale of 1 to 10, does that make sense? It must match, and ours is 28. Okay, it's Allen Bradley. It's a big pain in the butt getting all the firmware and everything. George, you made it. Getting everything to match, okay? So that's where we're at. Another thing that I got here, as you can see my IO cards. Here I got a relay output card, and I got an AC input card. And if I go right here and I do device properties, you can see that this card is a revision 2.005. Well, there's different revisions of this as Allen Bradley makes stuff. There might be revisions 3 or 3.1 or 4 and everything like that. But this just tells me what the revision is, and that could be helpful for you when you're going in your setting up your CPU to know what, or excuse me, your IO, to know what it is. And so, but what I mean by that is, here's my Studio 5000. You notice up here it says I use an L73 and it's 33, and I'm online right here. But you can see that you know, I haven't put anything in my backplane yet. I just put the processor in here. And when I first downloaded this, I actually put the processor in slot 1 by accident, even though mine's in slot 0. So remember, you can just double click this right here and it will launch this stuff. And then if you're offline or online, some of the stuff you can change online, some of you have to go offline too. But because it's in the slot, I definitely can't change that. But this was what you went in when you set up your processor, okay? Now, for my IO, and I went over this in the video before, if I go up into my controller tags right here, I'm going to click my controller tags, and there's no controller tags. That's because I haven't put any IO on it yet. Look down here. There's no IO. I haven't put any input modules or any output modules, and therefore I don't have any controller tags. And if I go to my parameters and local tags, there's nothing there either, because I haven't did anything. And even if I came up here and I said, you know, I wanted to make something that was, you know, push button, let me see, that's why, push button 1, and I wanted to make an alias, and I go for alias, there's nothing there. There's nothing that I can alias it to, because I haven't put in any IO yet, okay? And so what I want to show you is you were adding IO manually. You were going to backplane right here, and you were going to new module like this, right? If you're online like I am, I can go to discover modules. Okay, this is a little bit like the SLIC 500. It's actually not as cool. The SLIC 500 was really cool, the way that it went and set that up. Oh, it should have given me this right here. I'm on module discovery. I've been here for a while. That's why I wondered. Oh, there it is. Okay, and so it comes up. And notice it finds I got my Ethernet bridge here in slot 3, my input module in slot 4, and my relay module in slot 5. So if I want to go ahead and add this automatically, I just hit create. And the beauty of this is I don't need to know about the revision levels and all that kind of stuff. And I can call this AC inputs, and it already knows what slot it's in. I could give it a further description if I wanted to, but it says revision. Now, electronic keying compatible module. Okay, well, I got a few options there, and I want to go ahead and change this. What we did is we went in there and we disabled the keying on this. Okay, my options would be an exact match. Well, this is an exact match because I just read it right off the controller. It is definitely the exact one. The issue is that if I pick exact match here, and for some reason I don't go to the exact controller that I just exactly programmed on or anything like that, it will fault the IO. All right. So I hardly ever use exact match unless you want to lock down your program and your IO for that program to that specific rack only, and you will never use it anywhere else. And you know what the revision and everything is. You could use exact match. Compatible mode. I could use compatible mode module, and what that does is it will take a module and it'll take the revision level. As long as my revision level and it's compatible, it will take it. Well, same thing. What if I had a revision 3 module and I just wanted to transfer it? It's the same thing. It won't work. But what I like to do is disable keying, because generally a 1756 IA16, regardless if it's a revision 2, 3, or 4, will work with the program. So we are disable keying right here, okay? And so I'm going to click OK, and I would be there. And then we went in here about how, what your connection was, requested packet intervals. We'll get into this later about the speed of communication, but there's just some other additional module information, whether the module is faulted or not, what the configuration would be points. There's some diagnostic stuff in here that we'll get into later on when you do have a problem, okay? But anyways, I went and I discovered that module and I click OK. It doesn't matter. I could inhibit this if I wanted to. Inhibiting means that I could go ahead and put this in here, program it all up, get some code all ready, and then say download it, and then energize the new module, and everything would go in with, and the workflow would automatically get changed and everything like that. So there's my inputs, and I'm going to go ahead and create my outputs right here. This is a relay output card. And it's in spot 5. I'm going to come right here and I'm going to disable the keying again, and I'm okay there and okay here. Yes, that's fine. And I'm done here. I can close this. And now I've got my modules, and they match because I did it online discovery. So scale of 1 to 10, backplane, you can do a new module manually, or you could discover them, scale of 1 to 10. John, you like that? You see how you can do it? Yeah, I like doing that. Get this, ready? Once you go on and you discover everything, for the PLC that you're at, do a file save as PLC template. And then every time you start a new lab, just open that up, rename it as lab 10, then rename it as lab 11, then rename it as lab 12. And that time, every time before you start setting anything up, at least your IO is all set up. That's a pretty good idea, isn't it? Or you could go and set it up every time. Yep. Oh, that is smart. I know. Yeah. So anyways, I'm going back up here to my controller tags right here. Look at, all of a sudden I've got controller tags, and my controller tags are my outputs and my inputs. So they're there. I did want to go into my parameters and local tags right here, and I wanted to make this not, oh, I got it. Let's go into here, edit tags, give it to me. It's not gonna let me do that. I would want to come here, but yeah, I got in trouble there because I can edit the properties from here now. It kind of got me messed up. And so what I want to do is I want to make this an alias. It's going to even let me do this because I was screwing around with it. It's a local tag. I might have to delete this and get out of there. Can't do it. Yeah. So doing it, some of this stuff online and offline, this should have let me at least screw it around with a little bit. Yeah. And so you do not have as much power online to change these things as you do offline. But if you're in edit tag mode here, you can do things. But if you're creating a big bunch of tags, you know, in the tag editor here, you know, likely it's offline. If you're doing it online, you know, and here's what I am online right now, and I came in here and I just drag this in right here, and I'm going to drag an output in right here, and let's call this oops, that's where we went to the new tag, and then I would say PB1, and it's an alias for, it should take, no, alias, that's why it wasn't letting me do it. Alias for, what am I, local 4 input, and this is where you got, you know, it was a lot to drill all the way down into here like these, like there, and then I could create this like that, okay? And then for my output right here, I could do new tag, and I am just going to call this light 1, and it's an alias tag, yes it is, for my output module data 0, okay? And then I can just hit create and it's there. Now, notice I've got an eye over here because I'm actually online here. So you can edit online right here, and when you get done, you just click this green arrow right here. So finalize all edits, and I just click that, yes, and then boom, it's going to do it, and it downloaded, and I did an online edit. Okay, now I'm just going to come back. Editing already is kind of weird. Yeah, editing an existing tag. So I'm going to come back here, and this is going to let me edit it. This was it right here. I should be able to. Man, that's just a pain in my butt, isn't it? I guess I'll just delete it. Well, let me see if I can edit it here. I should be able to edit this. It doesn't let me doing that. You know, like I said, if you should be able to come in here and let me see if I can just do it. PB2 alias for, and that would be an input, and that go to data. See, you can do it here. That one just got away from me because I kind of started it, but I just made a PB tag here. This thing's just garbage. So if I come up here, I should just delete it, okay? So I made my other tag. I am making these tags online. So before I walk away from this software again, here's my main routine. Notice I got PB1 here. Oh man, I wanted PB2. Well, it's not go offline or anything like that and change it and download all this. It's this rung right here, double click. I double clicked it. I'm going to come right here, and I'm just I can search for it. Remember, you can search for it here, or you can just start typing like PB2, and it's going to kind of populate. Oh, there it is right there. Boom, PB2, and then click the green arrow right here, and then boom, it's done. So online editing is almost instantaneous, just like it was on the Siemens, and it's saved. Like if I were to come here and I were to go offline, it's here on my program as well, so that they match. So do you, on a scale of 1 to 10, do you feel good about the online editing? Double click, change it, click the green arrow, boom, and it's done. Yep, feel good, and you'll do a lot of this. Now the problem is you can't be a PLC hog. You can't hog the PLC the whole time generating your program online because your partner wants to download it as well. But really, when a lot of times when I'm programming and building something up, I do a lot of it while I'm online. Now, you wouldn't really do that out in the field because everything that you're doing online is going to affect the machine, and you don't really need to blow that work cell up by making all these online edits. But if you do need to just make something small, double click, boom, boom, change it, and click the green arrow. So you're going to become overly reliant on this, unfortunately, but you know, hey, it works good. All right. So I did that. Yeah, it is pretty neat. It goes fast. Configure the CPU, configure the IO rack. I did online discovery, and we ran through the IO. So so just scale of 1 to 10, from video 1 to what I just showed you to what you did in the lab. Is it starting to come together a little bit? You know, how to go ahead and get this all set up. You're going to get really good at it. I mean, you'll be flying through this software. You know, it takes a lot, but it's pretty impressive. Combination of the keyboard commands and a combination of copying and pasting everything. All right, great job of setting up the Ethernet IP. You're gonna have to do it again. We're probably gonna start running through the switch just because we'll have multiple things coming into there. Right now, your bridge has 2 Ethernet IPs on it, and so you can bring those through, but you're gonna have to bring it through. and if IP is not established, you're going to have to set that USB up. And I don't remember who we just couldn't get it to read, and then I came over and the metal plate in my head, and all of a sudden it connected. You know, sometimes that's the case too. But if your Ethernet, here's another thing: if your Ethernet IP is not working, what you do is you come here, you go to properties, you change it to automatic. Okay, you know, get out of there, relaunch this again, then reassign it as static. You might even go into links and delete it, and then, you know, back and forth a few times between static and dynamic, and hopefully it'll catch it for you. Okay. The CPU we talked about, that was, yeah, right. We just plugged it into a different port. No, that was me, man. It was all me. You were, it was because the metal plate in my head, I walked over there and bang, it worked, you know. But it's just magic sometimes. Sometimes it works, sometimes it doesn't. I hear you. So a different port, try a different port, the front to back. I don't know the answer. It's not anything special for me or for you. It happens to me all the time. And I'm like, I just know that I fought with it my whole life, so I'm just like, all right, come on, man, let's go. We can do it. Yeah, Cade. Yeah, I'm gonna beat you. And it takes multiple restarts sometimes. But a lot of times when you're connected, then you're just good to go. You know. Same thing here. Like when you were going online and downloading, remember you did communications, who active. You were able to come down once you had communications to drill down here into your bridge on my Ethernet here. Click that and then boom, download. And once you download that one time, you know, you can always then, you know, just go to the download out of here. You know, once it knows that connection, it's pretty happy. You get good at it. Let's see. The slot 1 CPU, it's an asynchronous scan. We're going to talk about that a little bit. We'll be talking about the asynchronous scanning of this a lot. It is really cool, and it's really just a butt kicker trying to get stuff to work all the time. CPU can be in slot 1, it could be in slot 2, it could be in slot 3. Unlike the SLC 500 where it had to be in slot 0, you can have more than one CPU on here. You know, it's a completely different. IO, you do need to know the correct slot that it's in, and it's input local. It's on the local rack. It's input. Here's an I. It's in 1, and it's bit 4. We had a couple of students mix up the 1 and the 3 slot. They said slot 1 was an output, but it was really an input, or slot 3 was an output when it was really an input, or something like that. Okay. So you just got to be sure that it matches. And then when you put it in, boom, you get a controller tag. And these are sourced and sunk, just like we learned in 260. We'll be doing a lot of other sourcing and syncing. But this trainer is, you know, hardwired. So there's not much you can do it. There's not a whole lot that you can do with it. I'm going to add one more thing right here, and this is going to be directions of lights and buttons. Okay. And so some of you, your trainer lights don't work. And so some of you, one of you, I know for sure, a trainer button doesn't work. So make note of that so that you can check it. Okay. And so what you can do if you want is you can come into here, into your controller tags, and here's my local IO right here, and I can do my monitor tags of this IO, local IO right here. Why isn't it coming on? Hang on. I want to put a value in there. Hang on. Maybe because I don't have it dialed in yet. Anyways, you're going to go into the lab on this. I guess I don't have mine all set up. That you can come in here and you can force this on. Let's see if I can get this to expand. Sometimes it's hard to expand right here. Get it, open. Oh, come on, go. There it is. Nope, I had it. Here's my local data. So that, you know, there's my local data right here. I'm monitoring it. And so what you can do, here's your binary. Here's another thing you guys were getting. You know, when you hover between these and you get that, you can double click it and it will show you the whole thing. But if I had my output device right here, this is my output card, and I change my radix here to decimal, and I made this right here -1, that just turns, oh, I wanted -1. How do I get -1? I want -1, unless it's a relay output card. It's all on. Okay. Yep. So a -1 right there, and that's a quick way for me to come and just turn, you know, all these on. This one should have been on as well. Oh, it's going off. That's smart. It turned that other one off right there because my ladder logic is turning it off, okay? But what you could do is you can come in there without anything hooked up, put -1, see if all of your lights come on your trainer real quick, just to see if it's working or not. I'm monitoring tags again, sorry. But I got a 0 there because my ladder logic's turned that one off. And so another thing, that when you expand this, here's the word or the data table. It's horizontal here, and it's least significant here. That, you know, I got output 0 off. This is output 1, 2, 3, 4, like that. But it also reads up and down. And so this 0 is that 0. This 1 is that 1. This 1 is that 1. It shows you the data point. So this is going to take a little while to get used to. That you're looking at the data table horizontally, like you've been doing with a Slick 500, but you're also looking at the data table vertically. They're the same. Like, look, if I came here and I changed this one right here, let's see if I can get in here and do this. Change this, get in there. I don't have a mouse, I just got my keypad. 0, watch right here when I hit this. See the 0 went right there as well. So it's 0, 1, 1, 1, 1, 1, 1, 0, 0, 1, 1, 1, 1, 1, 1, 0. So do you see how I'm looking at the data table here, and it's the same horizontally and vertically, scale of 1 to 10? How do you feel about that? Just digging in, looking at, yeah, you'll get, I'd say, yeah, 8's fine, 8, 9, 10. You'll get beginning the data table a lot and kind of seeing, like, I'll say, is this on or is this off? And you got to go up to your controller tags here, and you can just look at the hard data of the inputs and outputs and see if they're working, like we did on the Slick. It's just getting around this software, which is more complicated. That's why we learned on the Slick, and that's why we moved to Siemens, and that's why we moved to here. Okay, so hopefully that makes sense. So then the directions of the lights and the buttons, I just did want to touch on that. So what so I don't know if I remember right, but you got, you know, lighted push buttons like this. Okay, and so I don't remember the order that it is, but it goes like DI1 or DI0, I think. DI1, DI2, DI3, DI4, I think it's like that, like this. But the outputs go digital output 0, digital output 1, digital output 2. So the outputs run like this way, and the inputs run this way. And so you're thinking like, hey, I'm pushing, you know, this button, and this light's coming on. How come this light's coming on? It's a lighted push button, and they've wired it so that they have nothing to do with each other. One's just wired in, the input's wired into an input, and the light's wired into an output. And it'll screw you up. Inputs this way and outputs run this way. But you got to understand, it's just a lighted push button that has the push button and the light have nothing to do with each other. They're just wired into the input modules and the output modules. Does that make sense when I say that it's a lighted push button and half of it's an input and half of it's an output, and they have nothing to do with each other? Does that make sense on a scale of 1 to 10? Okay, yeah, pushing this button doesn't need to turn this light on. Pushing this button is going to give you an input. And if you tell it to turn this light on or that light or that, what, you know, that's the light that's going to come on. The push buttons and the lights, nothing to do with each other. It's just a lighted push button. All right. So that's another little thing that hangs people up. We did the tag creation. You could do the new tag question mark or the tag editor. And so, you know, question mark. So usually you would come and you would make all your tags or get pretty close. And then when you do your program, you can just come in here and you can pound in contacts and coils. You know, just start throwing. No, I gotta click this wrong. Oh, I gotta edit it. Sorry. You could just start, you know, throwing in your contacts and your branches and everything like that. And then if you have your tags created, then you can just backfill it all. You know, change instructions to whatever you want. You want a timer, throw this in here, double click this, go a TON, there it is. I mean, and so generate the ladder and the tags separately and then compact them. You know, you'll do a lot of that. And then the other way would be that question mark and kind of make it up as you go. And that's what the lab was. We did that in the lab. We did it both ways. Scale of 1 to 10, you know how to do it both ways. The last part was to make all the tags first and then program it. Okay, yep, I think you got it. Controller tags IO, we did that, showed you, you know, where they're at, what the type of tag it is, inputs, outputs, the location locally on the rack. We're going to do some remote I/O later, so that when you clicked on that, it would not say local, it would say remote, because it would be Ethernet IP. Okay. The program tags, I just ran through this. I did it for you, where it was an alias tag. Remember, the alias is just the name. Digital input 0 is not a good name. It is for us, I guess. But if it was, proc sensor on the robot, and then if that was the name of it, you're like, oh, I'm not getting input there. I bet it's on the robot. I bet it's the proc sensor. Like, you would give it an alias name, but the base tag data is the local, local 1 slot input data 0. Okay, so that's the difference between the base and the alias. This is once again is right out of the book if you read it. Now what do I got here? Create tags, create ladders, assign contacts and coils. That's what we talked. Show how to change instruction type. Yeah, I showed you how to change instruction type. I don't ever hardly drag instructions down off a timer counter compare. If I need something to be like that, I just go here and do a less. I do a less than LES, and then boom, I've got a less than command, or a GRT greater than, or a timer, or a counter. You just put in contacts and coils, and then once you know all the verbiage, you can do that. Or if you do want the compute math, you can come and do your compares, multiplies, divides, all that kind of stuff. Come here, you can type, MUL if you want, and do your multiply like that, or you can drag it down. Okay, everybody feel good about that? That you can drag your commands down here like in the SLC 500, or you can, if you remember the things, you can just change them. You'll get good at changing them because you'll remember. A lot of times you want OTLs for latching or unlatching bits, or XIOs, XICs, stuff like that. Program is not specific. That's with that one. There was a few problems in that because you just need to understand how to compile your errors. So if I come right here and I've got this, it's a mess. So I click compile and try and download it. It says yes. Well, it says I got an error here, and this is beautiful. So see the blue right here? I just click on this, and it takes me right to there. That's where my error is. And so when you get a massive program in subroutines and everything, and you click down and it won't download, just click on the blue thing right here, and it takes you to where it is. And you can see if I just delete this, and if I just delete this, and if I just delete this, it'll take this. Actually, if I try and download it, I'm gonna download it again. Let's see. Maybe I didn't. Oh, I didn't put anything on this tag right here. Right. So no argument on there. It takes me right there. So just click on the blue, and it will take you. Look at, there's a warning here. Shorted branch detected. All right. Shorted branch detected. It's not an error. It's a warning. It will download a warning, but it's just showing that there's a short there. Okay, so I click this, and now I download it. It should download. Let's see. I think I got download everything, and it's downloading and accepts it, and it's good, even though it's giving me that warning there. And then you want to get this thing out of here. You guys got to expand your screen from now on so you can see everything. You were too tight. All right. So any other questions about the lab? Like I said, we're doing a crash course here. I think that hopefully it made sense. I can run it. You can run it by me or whatever, but most of it, a lot of it right out of the book. All right. Scanning. So it says that the processor has two 32-bit unsynchronized process that goes on simultaneously. This is input, read, and write occur differently than what happens in the SLC 500 scan. So when we talked about the second generation SLC 500, what we did is we say we're going to check the inputs, and then we're going to check the ladder logic and solve it, and then we're going to update the outputs. So inputs, ladder, outputs, inputs, ladder, outputs, and then it sends a word to the backplane and writes the outputs. So that was the SLC 500 scan, okay? And so that was the traditional scan right here. Inputs, logic, outputs, inputs, logics, out. It just kept running like this. It read like a book. Read the first line, left to right, up and down, and then we get on with that chapter, read the next chapter, read the next chapter, then start again. It just kept reading over and over. Well, the control logic has asynchronous scannings going on, where our I/O scans are different than our logic scans and our communication scans, which means that these don't all necessarily sync up, okay? The scan times are configurable, but if you have a lot of logic, it might take a long time to scan that logic, okay? And it might not match up to what the inputs and outputs are. And they do have a watchdog timer on them, so if they get hung up taking too long to complete the scan, then there's going to be a problem. So this may not mean very much to you now, but when we start I/O in a couple weeks, I'm going to show you the asynchronous the asynchronous scanning issues that you're going to run into with your IO, and we'll just initially learn how to address it by learning how to map the IO so that it works. Okay, so that is going to be something that we'll talk about. Retentive, just some verbiage. Remember, an OTL, an output latch, has memory. If I have an OTL and I bring it high and I kill the power and then I turn the power back on, it still is going to be green. The OTL and OTU are highlighted, you know, when they're true. So if I came here and I made this, I gotta double click this to edit it, and I made this an OTL, an OTL, there's an OTL right there. And if I, let's just get rid of this, we don't need that. It's giving me an error. And I compile it, yes. And then there it is. And so if I come right here and I right click and I say toggle bit, and what it does, it just toggles this bit for a scan, and now this is latched on. But even though this isn't on, because it's a latching contact, simulated latching relay. If I kill the power to the controller and turn the controller back on, you know, it'll take a second to reconnect, and then this will pop back up to where everything's green. This will still be on because it's latched. Scale of 1 to 10, does everybody agree that the retentive nature, the way the retentive nature of a latching and unlatching relay works? That was the principle of it in 131 anyways, right? Turn it on and it's going to stay on. Same thing with timers and counter values. Whatever's in here, if it's a retentive timer, I kill it, turn the power back on, it'll still have that value, okay? Why is PB2 not on? Because I don't have a push button hooked up to this. There's no way for me to do it. I just wanted to toggle it like this. If I wanted to toggle this off, I could do this and toggle it, and I could turn it back off. Yeah, I just cheated a little bit, pretended that I pushed the button. Yep. Okay. Addressing, so timers for the SLC 500 was T4, and then you use the EN, the N, and TT. The logic is toggle's not. It's not like forcing. All it's doing is saying you know, close that bit or make that from 0 to 1 or 1 to 0 just for a scan. And so it's like I push the button for a scan. So just a kind of a way to kind of test your programs. The issue is, let me come back to here. Let's say I did have something here that was closed or open, and then I toggle it. Yeah, we're not getting into trends yet, but if this has a push button that's normally open or normally closed, and I try and toggle it the other way, it's going to just pop back to the way that it's wired. Okay, and so the actual IO will I guess override my attempt to toggle it, because really this is looking for the status of a push button 2 that's hooked on the 4 slot on the input on data 1. So toggling works, especially for bits, but remember your IO is going to supersede the toggle because that's the purpose of what the IO is supposed to be doing. So logics, once again, you name the timer and then you select the type timer for it, and it's predefined. It says give an alias to the predefined data. Yeah, I mean, it's a little bit farther down here. Like here's a timer bit. Like here we could call it things cycle timer done, or do you just want to use cycle timer .dn bit? You can still use the timer name and use this as .tt or .dn or .en, or you can actually just give it the whole thing a name done, and then like the lab showed, you could alias it to the timer done bit. So you could really give it the bits a name or an alias. Okay. Timer presets is in milliseconds, so 4,500, 4.5 seconds would be 4,500. Timer reset would need a name, something with the same name. So if it's what is this timer? This is cycle timer. So if it's cycle timer and it's retentive, you need a reset, RES, with that on it. Okay. So those are some things about timers. They're very similar to the SLC 500. We threw some timers in the last lab just for fun. All you had to do is program them to see how they went in. You're actually going to be using timers this time, so you're going to have to be put on your timer thinking cap to do this. All right, counters and timers, similar. Needs a reset with the same tag name. Counters count up, count down with a rising signal. So You program some timers and counters. Did it look just like the Slick 500? Do you feel like you got the timer timing bit, or the done bit, or the counter done bit? You know, the basics. Scale of 1 to 10. Do you feel good? You know, just about the timers and counters are just like the Slick 500. Yeah, they are. I mean, and you'll be doing a lot of them. And whether you want to alias all these done bits or just use them as a done bit. But remember, there's no more T4 or C5 dot done. It's blink. You give it a name. Blink timer dot done. Okay. Quiz review. No quiz. We'll do that. All right. So TON, TOF, RTO timers, once again, that is just, once again, the crash course that we did here. You bring it in. It brings in the predefined data. You brought the timer in, and then it had the preset, the accumulation, the EN to TT, DN. I showed you that on that other video. It comes right in. It's predefined. And you can create it with the new tag. Same thing. You can do it with a new tag window if you want. Do the question mark, give it the thing, and pick timer. And you can create it as you go. I can go right here, and I can just go. Once again, I can edit this online. Where's my favorites? Right here. I could come. What am I doing? No, I just go right here. So I can just go here, TON, and then timer. No, I don't want that. I want this to be timer. It wasn't going to let me do this right there. New timer. It's a data type timer. It's pretty smart. It knows, you know, whatever I would do this, I would create it. And then preset of 5,000. And you can just kind of create it on the fly if you want, and then compile it. And once again, if I go back to my parameters and local tags, I just created that timer. Here it is, timer. And if I expand it, there's my preset accumulation, ENTT, done. As I said in the video, these are Booleans. Your accumulation is a dent, because you have a number on it, and that's all your data, and your preset's a number here. So if I go to monitor my tags, get in there. I hate it the way it's doing it. My preset was 5,000, which if you want to look at it, once again, in Boolean, I do not like. That's one thing I don't like about this, is without a mouse, if you don't get that thing the first time, it misses it. But 5,000 is 00010011110011111. So part of the radix here is it. If you're looking at it horizontally, you can look at it as a decimal, and if you're looking at it vertically, it's showing you the binary version of it. But if you really wanted to look at this radix as binary, you could do that. And this 00100101111 is the same as 00100111101. It's the same. So up here you can. No, I know. you want to look at it. A lot of times you'll either look at it decimal or binary. We'll do, you know, a lot of binary math in here, and so most people like the binary math. When we get there, it's not that big of a deal. You're just getting used to programming it. And so once again, here's a 10-second on delay timer. Notice it's 10 seconds, so it's 10,000. It's in thousands. You know, you make this switch, it times up. This is how it's accumulating. And same thing, they're just using the enable bit, the timer timing, and the DN. They did not alias this as status timer running or status timer timing, or, you know, whatever. They just use the EN, the TT, and the DN bit. You can do that just like a Slick 500. Okay. Counters are CTU up, CTU down, same as before. One counts up to down, one counts, depends on the trigger. Coming true, it would go from false to true. It's going to count 1, false to true, count 2, false to true, just like a Slick 500. I don't think there's much different here. There are your bits that come with it. Your underflows, overflows. The done bit's the one that we use for counters the most, right? And then your preset and accumulation. So I really think you're good with the counters, the way that these go in. I don't know what else we can go. You can do new tag editor, or you can create it in the tags like you did in the lab. Counter, give it a name, bang, it's in, and you can use it. All right. Search enforcing. So I was showing you a little bit about how to override some stuff. The search enforcing is explained in the startup guide, which is part of the packet. So when I think I asked you to go in there and force something on, and that's different than toggle bit, because when you force something on, I can force on, you know, if I have an output over here, I can force it on. Okay, but in the packet, it explains how you go ahead and force things on, similar to you did in a Slick 500. Just be careful when you're forcing something on, that it could be dangerous. But if you're not sure if a light is working on your trainer, it might be burned out, force it on, and then say, that light's not working. Use a different light. All right. but there's just a couple things on the trainers. You might want to take a look at that. So do your search, and search is pretty good too. When you're trying to find, something, and you get a really long program, and you're like, God, what do I got to find? I'm trying to find timer. I don't know. Let's see what timer finds me. That's kind of a generic. Boom! It found it right there. There's my tag name timer. So if you have 100,000 lines of code and you're trying to find, something, and you were smart enough to give it a name that made sense instead of calling it Dorito, you can search right here, and it will go through and it will find every instance of Dorito or whatever you called it. And so the search is a great way to get through stuff. All right, and find stuff. All right, we are now about to get into safety relays. And we can take some time on this, but this is going to be a butt kicker. And so here's what I got for you. On the D2L, I put a lot of reading, and so on week 2 right here, I've got different items that you can read here about the timers. I got the data sheets; they're in their packet for how these safety relays work. I've got the 2-hand control safety monitoring. I really want to get to the one behind here, but I can't get to it. But there's a lot of different types of reading here about exactly how this works. If you're struggling at all, I would read the documents that I put out there. I'm gonna do my best to explain it. And, just like I said, with a lot of stuff in the book, I'm going to intro it and can answer any questions and everything. But really, there's too much that you're just going to have to read and try and sift through and figure out what I can do to help you with this stuff. But there's a lot. And so this is the stuff that's on the D2L. Okay. And so as we dig into the safety relays, let me just do this. How about a yes or no? Do you know what a safety relay is, and have you used one? Maybe that's one or the other. Kate does. Yes. You guys use safety relays? Yeah. Anybody else? You okay? So maybe this, sadly, yeah. Okay. Oh, we get a lot of good answers. Wonderful. Okay. So for you guys, maybe this isn't going to hurt as much. But for others it might. So the safety relay is used to inhibit the operation of a machine control device. That's what it is. We're trying to bring down the machine control device. We're not necessarily trying to bring down the motor. We are trying to inhibit the motor starter. Okay, for example. Okay, that's what a safety relay would do. It wouldn't directly bring down the motor, but the motor starter. Motors, robots, hydraulic presses, whatever. That's what a safety relay is. It's a safe way to turn something off. Okay, that's what a safety relay is. Now, here's what we know how to do right here. Let me take a look at this. This is a start-stop circuit. Start, stop, control relay. Everybody feel good about this, the way that this holding circuit works right here with a control relay. I would say 10s, right? It's just a start-stop relay. You could hook it up. If I gave you a stop button and a start button and a control relay, you could hook up a holding circuit, and you'd hit start, and the light would come on, and you'd let go, and it'd be on, and then you'd have to hit stop, and it would turn it off. Okay, that's right. So what safety relays are is that holding circuit on steroids. All right, they are redundant self-monitoring outputs that work on the principle of positively guided contacts. They only move together. And if one gets stuck, they all get stuck. So I'm going to just kind of go over my little safety training here. So as I just move away and plug this in, I'll be right back. I'm still right here. I'm not moving very far. Okay. I'm moving this under here. Okay. And I'm plugging this in. Hang on. I have this is on. And what I've got right here is I've got a start, stop, and I've got a relay here for holding. So I can hit start, and I can hit stop. Look at right here. See it? Start, stop. It's going off and on right there. If I just click this over right here by hand, I close the contact myself instead of doing the start, and I can hit the stop. You've hooked this up a million times, a start, stop. Now the thing here is, if I hold the start right here, and let's say a start button has contacts that close. If for some reason they get fused together, so that when I let go of the start, they actually don't open. Let's say the contacts are fused together, and that's what I'm simulating here. And then I were to say, oh no, Johnny's getting ground up, and you hit the stop. Well, yeah, it would go off. But as soon as I let go of the stop again, Johnny would continue to get getting ground up, okay? Or if I hit start, and for some reason, one of the contacts here in the relay, the holding relay or some of these other contacts get fused on, I'm gonna hold this indicating that it's on, and I hit stop, whoo, Johnny's safe. But as soon as I let go of this, it comes right back on because the contacts are fused on. So fused contacts, either on fused contacts, where'd that go? Either on the, this could be fused to start, the control relay could be fused, fused contacts. Do you understand what I'm talking about? How this could get fused on and there'd be no way to actually turn it off without killing the power. Feel good about that? I got a yes? Yeah, if you push the button, it's gonna come back on. You have to kill the power. Okay, wonderful. Now, here is the safety relay mechanism. And I'll see if I can get it all the way in here. It's kind of big. There it is right there. And it's pretty big. It's a little bit big. Okay. So what I got right here is I got 1, 2, 3 relays, and they're wired like this. I'm going to show you in a minute. These 3 relays are all wired together. But basically what it is, when I hit start, the light comes on, and when I hit stop, it goes off. I mean, hey, why not have a holding circuit with 3 relays when you could do it with 1, right? Well, this one's different. If I hit start, and for some reason, this gets fused on like it was before, and I hit stop, it goes off. But when I let go of the stop button, it stays off if the start gets on. I would have to hit start and stop again. Or how about this? I hit start, and let's say this relay right here gets held on, like I said before, and I hit stop. Well, before when I let go of it, it popped right back on. It stays off, okay? Even if I let go of this, it stays off. I would have to hit start, and then start and stop again. So this is set up so that if anything gets fused on, doesn't matter if you hit, it'll stop, it'll always stop, and it will only start if everything, it's called dual channel safety is what it's called. It's very redundant, okay? So does everybody understand this concept that there's no way that these contacts can get fused on and then stay on? When you hit stop, it's going to stop, okay? That's what this is showing right here, okay? Let me unplug it, hang on. Okay, wonderful. So what we got going there then, if I come back to here, is my control theory on this, is this. This is what I just showed you. Here's a control relay, here's a control relay, here's a control relay, and that's a safety relay. They have redundant self-monitoring outputs that works on the principle of passively guided contacts. Contacts only move together. So when we come here, we know that when CR2 closes, they're used when you need a higher level of safety. When you in a lot of places you need a higher level of safety. When you want to turn that motor off, if you need to turn it off, you need to be sure that it goes off. Whereas if you just have a simple start stop, if something gets fused on, you can't turn that motor off without killing the power. But if you definitely need, most times safety relays are red, you got to turn it off. That's where it's, and a lot of things do have these safety relays because it's a higher level of safety. Okay, so here's a CR2. Here's a contact for CR2. And then here's a contact for CR2, and here's a contact for CR2, and here's a contact for CR2. So when CR2, when this relay right here comes on, this closes, this closes, this closes, and this opens. Is that why you guys are reading this? When CR2 comes on, close, close, closed, open. Everybody agree with that? That's the way that this is reading? Because that dotted line indicates that all those contacts are okay. These are positively guided contacts. They are all or nothing. If this closes, then these are all changing state, closed to open or open to close. Whereas on a normal relay right here, I go like that. When I turn this on, depending on how this is, you can almost wiggle this to kind of get, maybe some of these to kind of come on or not come on if this isn't all the way in or whatever. The positively guided contacts, they all are forced to close together, and they're forced to open together. So like this right here, if this shut and these two burn on, these two get totally burned on, and I let go of this, well, all these other ones open, but these two stay burnt on. Well, on a positively guided relay, if I close this and this gets burnt on, when I let go of this, these all stay closed as well, because if one's burned on, it's going to keep them all closed or all open, depending on what they are. Okay, so they only work together. That's what we're talking about there. And so that is what is going on inside of the safety relay. And when you look at the safety relay diagram right here, you see this right here, and you're like, okay, this class is going overboard. You know, what am I looking at here? Well, the thing is, this square box right here, with all of this inside of here, you don't need to know what's going on inside of there. This is what's going on inside of there, but you don't need to know because you have no control over it. It's all hardwired. You only need to know what's going on outside of the safety relay. So don't get too hung up in here. I had a student that got so hung up on here, they spent 10 weeks and couldn't get past lab 2. This is just what's going on in there. You kind of don't need to know what's going on in there. Okay. And so this here is the safety relay. Okay. And so what's going on inside of there? Well, that's what's going on inside of there. And you really kind of don't care what's going on inside of there. All you need to know is this is the safety relay. And then these are the connections that you're going to make. Okay. So with that said, let's just take it the next step further. Here's this relay. When I turn this on, these contacts all close. I haven't lost you yet, have I? I turn the relay on, these contacts all close, all right? When I turn this relay on, let me use this is the one we use in class. When I turn this relay on, this closes, this closes, this closes. But you're like, well, wait a minute. This looks like 2, and this is 2 and that's 2. They're just redundant contacts. So when I turn this relay on right here, I get right here. It says 1 and 2, 5 and 6, 9 and 10. These close, right? This gets multiple contacts to close. 1 and 2, 5 and 6, 9 and 10, 13 and 14. So 1 to 10, before I lose you, you agree on this. Turn this on, all those contacts close. You with me on this? Got 10s? Okay, wonderful. So when I turn this one on, what this says is that I got this contact, which is 13 and 14. 13 and 14 closes. And 23 and 24, and 33 and 34, 33 and 34. And it's also got closed contacts. These ones open, and it's 41 and 42 and 51 and 52. So this one just has they look different. They look a heck of a lot different, and they are a lot different, but not really. All they are is contacts that are closing. Do you buy this the way that I'm explaining it? That if this thing comes on, 13 to 14 close. How do you feel about this? Does that make sense? Just like if you turn the other one on, 1 and 2 close. All right, you say that now, I hope so. The problem is getting this to turn on is a little bit different, okay? Getting this one to turn on, that was pretty easy. Let me go back here. That was pretty easy. Basically, you just had to hit the start button, and then the coil got voltage, and then it came on, okay? Well, on this one, remember, who cares what's going on in here? You have to make these connections externally here in order for this relay to come on. But when it comes on, all that's happening is it's closing internal contacts that, look like this, but you don't see them anyways, so don't get hung up on them, okay? So that's the safety relay. So the safety relay information that I just showed you is available on the D2L. So I encourage you to dig on the safety relay. I can't get behind this other one. Oh, this is a data sheet for monitoring safety relays right here. And this is kind of going to be the one that we're going to go over. So you have this document. You guys have this document in your packet, MSR 131 RTP. That's what you're looking at right here. That is the relay, one of the safety relays that you're going to be using right here. Okay, so hopefully you have that pack. Hopefully you have that in front of you. You guys have that in your packet. Am I correct in saying that you have that document you can look at? Okay. Here we go then. Let's see. Here we go. I got a couple things. All right. So week one, exercise one. And you got this too. You got this too. So I'll give you a second to get that out and be sure that you're ready. Where'd my, there's my sheet. Okay. So this is using the 131 or the MSR 130. Everybody ready to go? You got these two documents out? Yes or no? I need a second. Got these two documents, everybody? Yes. All right. You guys got them? Yeah. Okay. Need a second. You got a second. I'm giving everybody like 1 minute. How about this? We've been at this an hour. I'm going to give you 5 minutes. Come back at 7:15. Go walk around, stretch your mind, because this is going to be rough for those that aren't familiar with segments. 7:15. I will be right back. I'm going to get some more water, and then we'll do this. Get these documents out, and then we'll do it. 7:15. Be right back. All right, that was 5 minutes. You guys ready? Got a yes, got a few people, yep. Good, ready to go here? All right, I'm seeing yeses. Okay, so I'm looking at the wiring diagram for the MSRP right here. And some of these tell you know what we're looking at. Here is one for light curtain, so we're not using that. Here's one for dual channel e-stop. This is a nice one here that we're going to use. Here's a light curtain again. They're big on light curtains. Here's a single channel safety gate. We do a safety gate, and that's the latching for the gate. Shows you how to hook up the gate. Here's a safety mat. These are some of the different ones that are coming in here. So we're going to start with this one right here, a dual channel e-stop, monitor, manual reset, monitor output. And so if you look up here, it says e-stop. And the e-stop is showing one contact wrapped around to S11, S12, and a second contact wrapped around to S21, S22. That's an e-stop. And so the first thing to be aware of is that a stop button that you've used right here, this has one normally closed contact and it has one normally open contact, but the stop, we use the stop is one normally closed contact. And the e-stop has two normally closed contacts. So this would be red and this would be red on an e-stop. When I pushed it, it would open up this red and it would open up this red. So it's got two contact blocks on it that are normally closed. So scale of 1 to 10, does that make sense to you? Then the e-stop has two normally closed contact blocks, whereas the stop button only has one set of normally closed contacts. Difference between a stop and e-stop, okay? So that's where we're going to start with this. So when the first one says we want to hook up a master control relay, there's two ways to do it. And here's maybe the easiest one, where you're going to have line 1 and you're going to run to a stop button. Now remember, that's not an e-stop, okay? And you're gonna need a pencil and eraser for this, by the way. So then, normally you would go to your start button or your on button, right? And then you would go to your, your CRM right here. And then there's my line 2, and I would hold it like this with a CRM. So it's just be like a holding circuit. And remember, I usually like to put like an amber light here or something to know that the CRM is on, okay? So that's how we've in the past hooked up a start stop or an on off, CRM, okay? But now what we could do with this, if it makes sense, and I could draw the contacts, right here. But what I'm going to do, I'm actually gonna like take this right here just so you can really see it, and I'm going to run this through, one of these channels. It doesn't matter one. It could be 13 into 14, 23 into 24, or 33 into 34. I'm just going to pass it through these two right here and bring it back up to here. So I've broken this and I passed it through the safety relay. And remember, all you're thinking right here, everybody, is that this is a normally open switch that's going to shut when this safety relay is on. So now I've got two ways to stop this circuit, assuming that this is armed and this is true. I could hit the stop button and it would turn it off like it normally does. But if I hit start and it was on, if I killed the safety relay, that would also open it up as well, okay? So do you agree with this, that I now can open up the circuit here, or I could open up that circuit? Yes, 1 to 10 seem to make sense, that that's reasonable? Turn the safety relay off or hit the stop button. Okay, good. Now the question is, how do we get this safety relay to come on? Okay, well, in order to get the safety relay to come on, according to this, I need power. And so ours is actually 120 VAC, okay? And it's got a line cord on it. I'm just gonna go line 1 and line 2. Ours right here is just you're just gonna plug it in, and then you're gonna have power on it. Okay, so that's the first thing is power. Now it says I have an e-stop, and it says my e-stop, a dual channel e-stop, which I'd have to use like two. If I didn't have a dual channel e-stop, we'd have to cheat and use two e-stops here, but I do have dual channel e-stops, but otherwise we have to use the two reds. Okay, and so what that's saying is that I'm wrapping around between S11 and S12. So right here, if I wanted to, put a close contact here, I'll do it like that, wrapping around here, that'd be the first close contact. And the second one would be right here, and it's connected with a dotted line there, because if I push, one of these, it's gonna do the other one. And this one's wrapped around like that. So that would be my connections of S11, S12, S21, S22. So if I was taking this right here, here's S11, S12, and let's say if this was two reds, well then, this red is going into S11, and this red is going into S12. And then if this was also another red, well, that goes into S21. If this was red, it'd go into here, S21, and the other red right here would go into S22. So that by hitting this, I open up the top and I open up the bottom, and that's the two channels onto the safety relay. Hopefully you're seeing that. Stop me if that doesn't make sense. So a dual channel e-stop. Remember, this is all one unit right there. Okay, so I'm right there, and then I'm coming back to here. So I got S52 and S11 is jumpered right here. Okay, and then it wants a manual reset. Do we want to manually reset the safety relay? So it looks like right here it's got a push button between these two right here, S33 and S34. So I'm going to come right here with a normally open push button right there, and here's a normally open push button. So if I wanted to do that, S33 and S34, well, that's over here. So I would just run, that's the black, right? S33 going here, the S34 going here on that one. Okay, boom, hooked up. And so what would happen if I hit the e-stop? That would turn this off, and then this would be the reset for it. That's showing how that's going to get hooked up, if that makes sense. Okay, and then we need to say, is there any monitoring in it? We're not monitoring the status of a contact or anything like that. So what I would probably do would be to jump my Y1 and Y2 right here. This gets jumped, no monitoring. Okay, and so you're like, I'm not sure I understand this, but it goes like this. Plug it in, push this button right here, reset. And once you push that reset button, okay, these two lights will come on, channel 1 and channel 2. At which point, if you had your continuity meter, 13 and 14, right there, beep, they'd start beeping, right here, beep, and 23 and 24, beep, and 33 and 34, beep, they would close. This would close. Whatever's going, the magic that's going inside of here, assuming you had this hooked up, you hit reset, it would beep. At which point, this is, being treated like a contact that's closing, right? It's a contact that's closing, and then you're in business. Hit start and it comes on. Hit stop and it goes off, opening this up. So this first one, does that seem to make sense a little bit or not? You think you could maybe give it a shot wiring it based on this? Okay. You're going to have to take, when you get there, you'll have a safety relay to take a look at. Here's the other way you could do this. Okay. Well, the reset turns it on, and the e-stop turns it off. Okay. Yeah. That's it. The reset turns on, the e-stop turns it off. Well, what you could do Here's my line 1, kind of running around there. You could just take this line 1 and run it into, let's say, this contact. This is a completely separate way. We got 3 sets of contacts. You could just run this through here and run this into your CRM. And then just by turning on the safety relay, it would turn on this relay. The safety relay would turn on this one. Hitting the E-stop would open up those contacts and it would go off. Now, at this point, this only has an E-stop. The CRM doesn't have a stop. So you'd have to hit reset, be sure the E-stop's off, hit reset, and then the CRM would come back on. So this is a little bit of a harder start-stop of the CRM. This one, you have a stop-start on the CRM. It just go indefinitely. Unless you get a really big emergency, boom, hit the E-stop, kill it. You'd have to reset this, at which point you could start it again. So that's 2 different ways to do it. Do you agree that this seems just like a simpler way to just have the safety relay just kind of close the contact that turns the CRM on, and then you can use those CRM contacts to do whatever you want. Okay, 2 different ways to do this. All right, and you'll get into the lab, you know, of hooking this up and making it happen. All right, next one, let's do some more. This is draw the connection diagrams for a safety relay that used to start a motor, include a monitored output. All right, so I could go back here, and we're back here, dual channel ACE up, monitored manual reset, monitored output. All right, so we're back to wiring up. We're back to this one right here, okay? And it says what? Here's my line 1. I'm just gonna run it like that, and here's my line 2. Run it like that. Ours plugs in, boom, boom, and you just plug it in and it works, all right? We still need a dual channel E-stop. We want to hit the E-stop to stop it, and we learned the way to do that is just take this one, which is closed, and wrap it to there, which is just a, you know, it's just a dual contact here running to there. So this is my E-stop right here, which kills it. It says you're still gonna want to reset. We'll put a reset on it, which is, you know, 33. You think about this reset, or, you know, it's almost like an on. So there's my push button for my reset. Wire that, reset on. And then at this point, it won't come on because I haven't addressed the monitoring yet here of line 1 and line 2. So the monitoring is the relay, the safety relay wants to know if the other relay's on or if the other relay's off, okay? It only wants to reset if the contactor is in the condition that it's supposed to be in, you know, in this case off, all right? And so if I go to this right here, and I'm looking at this middle one again, before we jumped Y1 and 2 together, we just jumped them because there was no monitoring, okay? Well, now what we're doing is we're running Y1 and Y2 through the closed contact of the motor starter or the contactor, okay? And that's what this K1 is. K1 is a contactor. Now we're doing dual channel safety. So why start a motor with 1 contactor when you can start a motor with 2 contactors? I mean, what are the odds of a contactor failing? And it can fail. What are the odds of 2 parallel contactors failing at the same time? A lot lower. So instead of having 1 contactor close line 1, line 2, and line 3, let's put 2 contactors right in series. Does everybody agree that that's what you're looking at right there? Is that you're looking at 2 coils right in series that are closing together. K1, it's called K1 and K2. That the top one's the first relay, the bottom is the second relay. We have two contactors. All right. So what we're doing is we want to turn on, and here's our load, 13 and 14 is going to, you know, we're passing power into 13 and 14. And in order to turn the motor on, we have to turn on the contactor. So I'll draw it you know, I'll draw NEMA instead of IEC. IEC would be K1, but hey, if you just want to go like this and put a C on there for a contactor, I guess, or an M, a contactor, C1, C2, I don't know, however you want to do it, K1, K2, those are your relays, relay 1, relay 2. I want to turn these two on because down here I've got C1 and I've got contactor 2. See, I'm not used to using C's or control CRs or anything. I'm used to using K's. There's my motor, by the way. I got to turn this one on and this one on in order to turn that motor on. Okay, and that's my voltage coming through here. And so once the safety relay comes on, these two are going to get voltage, which are going to close this. But it says it needs to be monitored. And so Y1 and Y2 go through the closed contact of C1 and the closed contact of C2. That's my Y1 and Y2. So if for some reason this thing is not off, if these contacts are not, because they're positively guided contacts, in order for, if this C1 right here is closed on a safety contactor, because it's positively guided, this one's closed and this one's closed and that one's open. On a normal relay, some of these can be open and some of them can be closed if they get burnt together. But on a safety contactor, if this one gets burned on or this one or this one, these contacts are going to be closed, closed, open, closed, 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 open. Does the burnt on positively guided sense of this make sense to you? That you're getting all or nothing on these contacts. The scale of 1 to 10, does that make sense? It's all or nothing. There's no partial closure of some of the contacts. They're all closed, they're open like they're supposed to be. That's a safety relay. Okay, so what the safety relay is checking is to say the contactor is off because it's a closed contact. And so we're looking at, you know, number 3 and 4 right here, and it's closed. Well, if one of these is burned on, then that's going to be open, and then this will not reset. This safety relay just will not reset, just like the way that I showed you with my little trainer. Okay, so this is the situation of using a 2-channel E-stop with a manual reset, turning on dual safety contactors, which would be K1, K2 really. The K1, K2 to turn the motor on, and it's monitored. It's monitoring the condition of K1 or contactor 1 and contactor 2. That's what this one here is showing. Okay, so we'll be doing these for a couple of weeks, and they'll get better and better at them. So, and I know that this is a hard ask because you're still getting there. The way that I explain this one, scale of 1 to 10, where do you think you're at with it? You know, early on in the course. Yeah, 9, that's pretty good. 8, okay. These are pretty, 7 to 8. Yeah, you know, it's all right, and some might be lower. These are pretty good. Like, we're going to do them, all right, and we can hook them up and wire them up to be sure that they're going to work like you want them to, all right. But you guys said that you had worked with safety contactors and safety relays before, so at least we're there, all right. Palm relay and literature. So it says you really want to only replace them. Yeah, I know. The GM was what did they do? Oh, GM was telling me a story they were in that they went through and replaced all their safety contacts, other pills contactors, and really it was just like, yeah, take out 8 wires and put in 8 wires. But to actually try and troubleshoot one, nah, forget it. Put it in the garbage and just install a new one. You know, I agree. Review the literature. Now, I recommend all this literature is on the D2L. You want to take, you know, once again, take a look at it. And so, you know, here's the pills, you know, oh, that was the 2N one. What's this? This is, oh, I want that other one. It's hiding under there. Bear with me. Hang on. Oh, here's one. Here's one for the, let me get in there. Let me move this over side a little bit. This is pills or Phoenix Contact safety relays. You know, at the beginning of this, there's a lot of stuff just talking about safety relays. But, you know, once you get down in here, It does some cool stuff. It shows you, a lot of different applications. Let's see if we can find some simple ones. What's this? For pills. That's too hard. But every application that you might want. What's this? A two-channel emergency stop monitoring. Okay, look. E-stop 1, E-stop 2. They're a single button. So there's my two-channel E-stop right there. S11, S12, S22. Hey, those numbers look kind of familiar, don't they? They were just on our sheet. No matter what color your relay is, if you're using pills or Phoenix contact or something that's yellow versus red, these numbers are the same, right? Oh, look at 13 and 14 close, beep, or they open, no beep. 23 and 24, beep. These close, beep. 41 and 42 are normally closed, beep, and they open. All right, so there's my contacts. Look at this. Oh, here's my monitoring right here. Look at, here's my safety contactor 1. Here's my safety contactor 2. I'm turning on double safety contactors to turn on the motor. Okay, that's all this relay is doing, is closing these two contactors so that the motor will come on. And then guess what? You can't actually turn any of this on unless K4 is off, K3 is off, and then it's reset. You got to push a reset. Oh, that's cool. Put the reset button, in series there. This is a reset. So you can go through and take a look at some of these applications. What's with the X with a circle on 42? On this one here, or on ours? Oh, this right here. Oh, this is going to be some type of monitoring device. Could be a light or something to say that. No, this is going to be like some type of monitoring device. The load, remember, the safety relay does not bring down the load. Its purpose is not to bring down the load. That's the controller. And in this case, the controller are the safety contactors. It brings down the controller that brings down the load. All right. So the safety relay brings down the contactors, which bring down the load. This would be a way of monitoring it here, right here, with these close contacts, like a light. Say if this is on, then you know that this is closed like it should be, or it's off or on or something like that. Okay. But once again, it looks like here. Oh, here's two separate. There's an E-stop. Two-channel E-stop. So you can go through and look at these as we get into these. Oh my gosh, look at this. Here's 4 contactors. Oh, dual motor starter. Oh, I love it. Look at this dual motor starter. You're bringing on, obviously a lot of contactors here. K3, K4, K5, and K6. Two safety contactors for each motor. That's what you're passing through here. And then all those motors you want. Looks like you want both motors all the way off. All 4 contactors for both motors got to be off before you reset it, so 2-channel emergency stop, cross circuit detection. I mean, there's just tons of ways that you can go with this. And this little thing would, break it on. Oh, this one's easy. Look at this. We'll do one more. A single contactor turning on a motor. Yeah, that makes sense. That's what you've learned so far. So yeah, this isn't quite as safe. This is a stop category 0, where those other ones were a stop category 1, a higher level. But it's just a single contactor turning off the motor. And guess what? There's no monitoring. I don't see the close contact of K3 here anywhere. So in this case, the relay doesn't actually know if the motor's on or off. Whereas on these right here, once I put in the close contacts of the motor starters, then the safety relay actually knows if these starters are burnt on or burnt off. Okay, so once again, small steps. Do you agree with that? That this one's got the feedback from the contactors are wired back into the safety relay, so the safety relay understands at least if the contactors are off or on. Where this one up here, everybody seeing that? This doesn't have any close contacts wired into it, so this relay is kind of dumb. It doesn't really know if the contactor's on or off. There's no close contacts, right? So, this is a good document to go through and take a look at and try and understand some of the things for this. But I did put, just tons of literature out there that you can take a look. And that whole principle and philosophy of how a safety relay works is on the D2L if you want to read it. I mean, we can do some more. I got literature and packet safety relay 3. We can do another one. Let's just do one more for the heck of it. I don't know. What do we got here? Draw a diagram for a safety relay that has a 2-channel light curtain emergency stop monitor with cross-circuit protection. All right. Safety relay 2-channel light curtain. Light curtain monitored manual reset. Manual reset cross-circuit. That looks pretty good right there. Let me see. There's another light curtain. Light curtain monitor manual reset, no output monitoring. And it depends if we want output monitored or not. Let's do this one. So I'm going with the first one. So once again, if we wanted to, according to this diagram right here, basically we got line 1, line 2, ours powers up, plug it in, boom, it's on. In order to, wow, that's crazy. I don't know if we need to do this or not. I mean, I'm just, basically what I'm doing is I'm just reading, you know, what it is off of here. You would see that a light curtain controller has 2 channels. It says channel 1 and channel 2. Just like a 2-channel e-stop would have closed and closed, any kind of DCS controller, dual channel controller, dual safety controller, is going to have 2 closed contacts that open up at the same time. And that's really what this light curtain is showing. Channel 1 and channel 2 are going to be open. And without getting too crazy, I guess the moral of the story is that this light curtain gets wired into where it's looking for closed contacts, 2 sets of them, 2 sets of closed contacts because of safety relay. And then it wants to reset. Once again, it looks like it's got a 34 and a 33 and a 34. You know, you got to push the button to reset it. This one, the Y1 and Y2, it is running through the contactors. So the relay wants to know if the contactors are already open or if they're already closed. Okay, so that's why it runs through the close, you know. And there's my contactors that I'm turning on. Was that what this was turning on? 2-channel light curtain, didn't say what it was turning on. So I mean, these diagrams look a little bit scary, as do these diagrams look a little bit scary, but really they're not that bad. You just kind of take a look at, you know, what your diagram is, and then you can kind of look and see, you know, which screw terminals are what. And I've got them labeled here, you know, once again, because we use banana jacks, okay? And then you just need to make those connections depending on, you know, you're doing light curtain or you're doing push button e-stops or safety mat or whatever. But, you know, generally, they're kind of all the same. They're looking for, oh, look at this one. What is this? Single channel emergency stop monitoring. Well, this is kind of dumb. Look at this. This is dumb. The emergency stop kills the power to the thing, which it's probably locking, you know, locking e-stop kills the power to the safety relay, which opens up the contactor, which turns off the motor. Okay. And so, all right, reset the emergency stop or pull it out. And then the only thing to turn this back on is to hit the reset button because your safeties are jumped. So basically this is like a little stop start. That's all this. Stop, start, stop, start. But it's safer because of all the redundant contacts in here. That's a really simple application right there. And you got to hook that up. You're saying, wow, that's weird. Well, you just get right here. It says S11 and S12, S21 and S22. Here they are right here, jumpered. All it's saying is, you know, jumper these right here, boom, jumper these right here, boom, you know, hook up my reset on the S33 and S34. There's my button going, my button's going right into here. And then my e-stop, that's what's weird. It's the e-stop was bringing the power down. And then you could, boom, you'd be in business on this if that's what you wanted. So like I said, they look a little bit scary, but you know, just trying to identify the, you know, the contacts that you need to get them wired up to do what you want. All right. Right here, I'm looking at data sheet. This, oh, that's the monitoring relays. Here's the 2-hand control right here. This is an anti-tie down. And so when this is hooked up, what this does is this says that you must, it's all wired internally, and it's for presses and stuff like that, so you don't get hurt. This is saying that, you know, you have to push 2 buttons pretty close to one another in order for the stamp to come down. And these are usually far enough apart so that you can't go like this, so that your other hand could be under the press and get cut off. These are far enough apart so that you have to push them. You guys know what I'm talking about? You've seen this before where you have to push two buttons in order for something to stamp so your hand's not in there. Yeah. And so if you went like this and then waited a second and pushed this one down, nothing would happen. It would be timed out. It's like this has to be pressed within a quarter second of the other one. So there's a slight time delay in it, okay? That's what this does right here, this two-hand relay, okay? And so, you know, once again, if you come here, you know, it kind of explains the operation. And here, it's showing, you know, the circuit wiring example of it. And so look at 13 and 14. Does 13 and 14 scare you? 13 and 14 closes. It's like 1 and 2. It's like 1 and 2 on the normal relay. Does 23 and 24 scare you? It's like, you know what, it's like, you know, 5 and 6 on this relay. It's just, you know, sets of contacts that are closing. So when you start looking at this, you know, you got to try and look at this. But here's the thing. This dotted line right here that's running around the relay right here, this dotted line, everything inside of here means nothing because you don't have any access to it. Everything inside of there is what's inside of here. And you don't really get, even if you did open this, there's nothing you can do with it, okay? So as I say that, do you guys recognize that this is the internals of that? Okay. So look at this. What does this dotted line right here mean? See this dotted line right here, how it's coming around here? That dotted line. What do you think that is, anybody? That dotted line represents? Any guesses? Looking at this diagram. Oh, here's another dotted line. There's another one right here, this dotted line coming around here. Enclosed in the switch. They do move together, absolutely. Right. These are external, but it's labeled. Look, what does switch 2 mean? What does switch 1 mean? It means there's 2 push buttons on this thing. It's a two push button. These are my 2 switches that have to get pushed, right? And the components of that switch are inside of here. So let's look at switch 1. Here's switch 1. What does switch 1 look like to you guys? Tell me what you know about according to the logical reference. It's going to be kind of the direct relationship to it. You know, obviously it's not a pictorial diagram, but it's just the wiring diagram of it, you know. So tell me what you guys see about switch 2, for example. Looking at switch 2, what do you see about switch 2? It's a PB with a normally open and a normally closed set of contacts. One normally open and one normally closed. I think that's what it looks like. Have you guys ever seen a push button with one normally open and one normally closed set of contacts on it? I don't know, man. I mean, have you ever seen a button with one set of normally open and one normally closed, set of contacts on it? So that's John, what you asked. That is representing this. So you got to be able to look at that diagram when you start wiring this up and say, oh, yeah, can't kind of see this, right? And then, you know, assuming that you can get this hooked up and that you can push these switch 1 and switch 2 within a quarter second of each other, then 13 and 14 will close. And 23 and 24 will close, and 34 and 3 will close, and you'll have 3 switches that close. That's the way this safety relay works, and it works as a 2-hand control, or an anti-tie down is another way, is what it's called, anti-tie down. All right. So that's you know, what I want you to do is take a look at that kind of stuff. All right. The lab is pretty extensive. and you're going to want to take a look at the lab ahead of time. Especially there's a programmed anti-tie down in there where you could do it with timers. Instead of having the safety relay do it, you could program timers, and it could take you 5 hours just to figure that out. If you arrive at class and just say, "What's an anti-tie down, Sean? I've never heard of this." Well, you're in for a long week. I would definitely take a look at the lab and read it. And I don't know. I'm not. I don't want to be mean. I'm just giving you advice. Some of you won't read the lab. You're just going to show up to the lab and get spanked pretty bad. Others are going to come to class prepared and move through this in an orderly manner and try and figure out what's going on. I'm here to help. Yeah, take a look at it. I'm here to help. If you want to come in the lab this weekend and start programming stuff and organize, and at least if you can't figure out part A or the programming part, move on to part B and get part of that done and at least get partial done. I don't know. Somehow have a plan to get this lab done. Otherwise I'm not being mean. I just won't have a lot of sympathy for you if you show up and you have no idea what's going on. All right, that's my and I'm here to help. I promise you I'm here to help. I want you to learn. But you got to be prepared. Got to read a lot. So the labs: timers, counters, safety relays, sourcing and syncing IO, forcing online entity search. I got one more thing I got to show you before we go as we move forward. Okay. So when I have my safety relay right here, maybe you can do this on number 3. And if I had a 2-channel gate or 2-channel e-stop, I'm just going to stick with the e-stop for now. Okay. I'm just going to throw the e-stop in here just like we did a minute ago, because the e-stop's simple, right? Could be a mushroom head. And then I'll put a reset on it. You could have that'd be an automatic reset. I'll put a push button reset on it, reset, and I'll put no monitoring. There's no monitoring on it. Okay, so this is my e-stop. This is my reset. I'll spell it nicer. Reset. Okay. So another way to do this is if you want to bring down the machine controller, if the machine controller is running through the PLC, everybody, you can do this. When this gets all reset, pick a channel, I don't care. This one, or this one. You could run voltage into here. You could run it out. This would be V1 of my output card. And then this would be my sync, my common, right? And then therefore, if this was going to, solenoid, and this was going to motor starter, and this was going to, light, whatever you got going, that's my outputs on my card, right? If the safety relay brings down the voltage that feeds the card, I'm pretty sure that, none of the devices that are wired into the card are going to work. You know what I mean? So that's another way to do it, is bring down the sourcing of your output module. Jeff, that was too fast. I couldn't see what it said. Will you might have to type that again or just hit or copy and paste because I missed it. Does that make sense, everybody? How you could bring down the output card completely. And then anything that's wired into we do that almost every motion output card. That's right. Yep. Bring down the output card. And then you bring down everything that's wired into the output card. So in order to get the output card to work, you have to just reset the safety relay. And then boom, instead of having a master control relay turn on the output card, have the safety relay turn on the output card, I guess, if you think about it that way. All right. So, and remember, this is just this safety relay. This 2-hand could do the same. There's all kinds of different safety features that can get programmed into a safety relay, the functionality of a safety relay, that really just closes 2 contacts, 33 and 34, that gives voltage to a contact, or gives voltage to an output card, or gives voltage to a robot, or anything. But the safety relays, this whole thing you know, these external connections are just trying to get this safety relay to come online. So you guys that are coming in tomorrow, you might just get this right here and hook it up right here with no monitoring, Y1, Y2. Just don't put any monitoring in Y1, Y2 right there. That's what I got right there. Put some push buttons into here. Actually, this would work just like this would come on right here, won't it? Let me just plug this baby in. I'm kind of curious. I never really did this before. There's no monitoring. Oh, I gotta need a reset. Sorry, hang on. Bear with me. I'm having fun now, guys. Then I'm gonna let you go. I'm having fun. Just give me a second. All right. So I'm here. Plugging it in. Give me a second. Hopefully it doesn't short everything out here. And my channel, I got channel 1, channel 2 here. And if I had a push button right here across, you know, this here's my reset. It reset. These are on. And what was my stop? My stop was any one of these. Boom. It's off. And this one killed that one, by the way. You only got to kill one. But then 33 and 34 right here. Those are my resets, 33 and 34. So I'm just, you know, I'm just faking a button here. Watch up there. Here's my reset. Ready? It reset. So, you know, my e-stops are normally closed. So I just jumpered them like they're normally closed because that's what it is. And there's no monitoring on there. So I jumpered it like it's closed. And then boom, I can fake an e-stop right here. Fake an e-stop. Hit the reset. Oop, what did I miss? Hit the reset. It's an e-stop. It wants both channels to go off. You have to hit the e-stop, and then you could bring it back on. Boom, it's back on. So my little demo here, really dumbing down the operation of this. I don't know, does that help at all? You know, maybe a little bit. You know, just a little bit, kind of screwing around with it. I mean, I didn't put any push buttons on it, but I was able to get to reset just by jumpering everything. You know, really, you would have push button reset and dual channel e-stops and all that. So, by the way, if you come into class and try and do it, I don't think I have the dual channel e-stops out. So this first push button here, you're going to have to wire it into the red. And the second push button here, you're going to have to wire it into the red. But when I get to class next time, I'll have a single one that's got 2 reds on it. But you could use two e-stops if you wanted to screw around. What are X1, X3, X4 for? Where's that? It just depends. Like you'd have to get into the MSRP document and go all the way through about what you would want them to do. I don't know that in this model these are used for anything. Actually, I don't know that they're used for anything, but they use this same platform. They use the same platform to build up other styles of relay, and they might use those for something else. All right, so that's the lab. I really think you should take I highly recommend that you take a look at it. Okay. So it says quiz and lab. The quiz is open. It's just a real simple time, 15-minute multiple guess over, you know, what we learned last week. Looks like Gates and Maths could be. Else that we need to have done. I think homework in lab 1. The quiz is open till midnight. No, I think you're all caught up. I think if you have your homework turned in and you're going to take the quiz now, and you've already turned your lab in, so you know I think everybody's kind of caught up. I had one student who talked to me. He had some stuff going on, and he's going to make it up. So I think we're all dialed in. So what I'll do is I'll stop sharing here real quick, and I think we're pretty good. And hopefully you guys like the online lecture, and I'm giving you enough information, and I'm just trying to help you. A lot of this is on your own. You got to read the textbook and understand it. You got to read the lab and understand it. You got to read the documents online and understand it, and then ask me questions, and I will knock myself out to try and help you out. But man, you got to really be prepared for this, because this is like the real world. I'm running this baby just like it is when you get that $50 an hour job to try and figure out. The quiz is open till midnight tonight. Yep, the quiz will be open for the next 4 hours. That's what I got for you. Go take the quiz. I'll stay around for an office hour if you need it. And then have a good weekend. That's what I got for you. Say that now. All right. You guys can get access to that quiz. I just want to be sure. All right, the quiz is open, so you guys are rolling on it. That's good. Yep, have a good night. Thank you.